All right, we're going to look at page 93 and 94 in your guided workbook. So this section is talking about some different Excel formulas that you can use in terms of finance. One of them will calculate rate. One of them will calculate the number of periods required to pay off a loan or to obtain some sort of goal. Um, PMT payment will calculate the amount of a monthly payment or a month or a payment. PV is your previous value, and FV is your future value, which means how much you intend to make in the future. So, what they're doing, I'm going to show you a couple of different things. I'm going to show you the formulas, the way they would appear in Excel, and then we're going to go to Excel and look at that also. So the first question says, what is your monthly payment on a $23,000 car loan at 8.75% for 5 years? So back in, I believe, chapter 3, we learned a payment formula. So this is our payment formula, and it was the amount of principal, the amount that you borrowed, the annual percentage rate, number of periods is N, and T is the amount of time, which is the number of years. So if I substituted all of this into my formula, I would come up with this answer, and we're going to talk about this spreadsheet, and you'll see what the actual answer is. So in terms of the Excel formula, there's a formula called PMT, which is payment. The first thing in the formula is your rate. The second thing is the number of periods. The third thing is the payment. And the last thing is the future value. Now, the future value, because it's in brackets, means that it is an optional value. Um, so in this case, our rate is 8.75%. We're going to divide by 12 because we're talking about monthly payments. The number of periods, it's 5 years for 12 months. The payment amount is $23,000. Okay, and then the future value, what we want to have is a value of 0. So this will calculate the amount of payment necessary to pay off this car loan. So we'll look at the spreadsheet in just a second. The second problem, the annual percentage rate that you need to guarantee yourself an annual payment of $60,000 for 25 years. If you have $1,200,000 in the bank and you anticipate having nothing left at the end of the 25 years. So here's what they're talking about here. You have $1,200,000 in the bank. You want it to be able to collect interest over time, but every year you want to take out an annual payment of $60,000, but you want it to last for 25 years. So what would be the rate that this money would have to be collecting in order for that to happen? So our formula for rate is number of periods. Second thing is the payment. The third thing is the previous value, and the last thing is the future value. So in this case, the number of periods is 25 because there's 25 years. The amount of the payment is $60,000 because that's money that's coming to you. The previous value, this gets a little tricky, is negative $1,200,000 and the future value is 0. So the reason that the previous value is negative is because it's money that's actually in the bank as opposed to in your possession. So in this particular case, um, excuse me, the $1 million is negative because the bank has it, not you, and you're paying money out to yourself. Okay, and we'll look at this again on the Excel spreadsheet in just a second. The third example, how much money would you end up with if you make $650 monthly payments to your retirement account and the retirement account earns 11.3% interest for 36 years? So this is a future value problem. So future value has rate, number of periods, payment, and previous value. So our rate is 11.3%. The number of periods is 36 times 12 because it's monthly payments, because you're talking about doing monthly payments. The amount of payment, again, this is money that you're going to be putting into your retirement account. So it's going away from your possession. So it's $650. And the previous value is zero. You started off with nothing. Okay, so let's take a break for a minute and look at the Excel spreadsheet and what we've got for that. So what I did with this is, if you look at the first problem here, this is problem number one. Okay, so for problem number one, I typed in exactly what we had on our paper, which is the 8.75% divided by 12, comma, 5 times 12, comma, 23,000, comma, 0. And I got $474.66. So I want you to pay attention to the fact that it's red and it's in parentheses. So it means it is a payment that is going to the bank. It's going out of your possession, so it's technically a negative value. It's leaving your possession. So if you make a payment to the bank, it's money that you lose, that the bank gains. Okay? So that's why it's coming up as negative. Example number two, I typed in exactly what we wrote on the paper. So rate 25, comma, 60,000, comma, negative 12, negative 1,200,000 and 0, and I come up with 2%. The third example, the future value, if I put $650 in, would be 11.3% divided by 12, because it's monthly payments, comma, 36 times 12, comma, negative 650, comma, 0, and I end up with $3,888,826.87. So then I did another thing, and I actually did example two. So here we have example two, and I started off with $1 million. $1,200,000, and that's month one. And on month one, I am going to pay myself $60,000, and I'm putting in here the 2% interest that we did as a calculation. So here, what I've done here is I took the $1,200,000, I multiplied it by the interest rate, the 2%, and then I subtracted out the $60,000. And this is how much money I would have in my account at the end of 1 month. So it would be 1,164,000. So I started off with 1,200,000. I now have 1,164,000. And then in month two, I started off with 1,164,000, and I ended up with, after interest has been accumulated and the payment's been made, 1,127,000. So you'll notice at the end of 25 years, I end up with $46,000 left in my account at the end of 25 years. So that means that my account did end up paying me $60,000 every month for 25 years. Okay? I'm sorry, $60,000 a year for 25 years. So what if I change this to 1%? So now look what happens. At the end of, if I only got 1% interest, I would run out of money. See how I've got parentheses around this? So that means that these values are negative. I would run out of money at the end of 22 years if I only had 1% interest. If I had 1.5% interest, okay, I would run out of money at the end of 23 years. I would have $56,000 at the end of 23 years. So that's what this is talking about with spreadsheets. I'm able to come up here and change just this one value, and I can see, whoops, I'm sorry, I should have done 0.02. I can see how that one value is affecting the whole spreadsheet without going through and retyping a whole bunch of values, because I'm using these reference terms in here. Okay, here's example three. So example three, I started off with $650. I got 11.3% interest. Okay, and this is how much I have in my account at the end of month one. And then for this part here, I added $650 to that, because every month I'm going to put $650 in. So I had the $656 down here plus the $650. I got interest on that, and I keep doing this, and at the end of, um, I forget how many years it was, at the end of 36 years, which is a whole lot of payments, here we have 432 payments, I end up with the 3,888,000 that we had talked about. Okay. All right, so then we go to example 4 on our paper. Okay. And on example 4, what they want you to do this time is write out what would be the calculation instead of if I had to do it by hand if I didn't have an Excel spreadsheet. So these types of calculations are just exponential calculations. So we're taking the previous value and we're multiplying it by 1 plus the rate raised to the number of periods. So the previous value, let me move this out of the way, is $10,000. The rate is 5%. The number of periods is 2, and I would end up with, if I put all this on my calculator, I end up with $11,025. Okay, let's look at the other two examples. Now this problem, you would not be able to do problem 4b without using logarithms, and we haven't talked about logarithms, and we don't plan to talk about logarithms, so you wouldn't be able to do this by hand, but we can do it using the Excel spreadsheet. Okay. Number C, or 4C, again we're using that same formula to find our rate. So this time we knew the future value, we knew the present value. We're trying to find the rate. So right here I'm going to divide by the $1,000, and that's where I get the 1.21. And since it's raised to the second power, the opposite action mathematically is do the square root, and I end up with 10%. Okay, on this next example, here's what they're asking you to do. They're saying, I want to know the future value if I have a rate of 4%, I have 3 periods, I am making payments to the bank because it's negative of $1,000, and I start off by putting $500 in the bank. So I put $500 in the bank. Okay, so on month 1 I put $500 in, and then another month or another year or another period elapses. Okay, so the next period shows up and I put $1,000 in the bank, but there's already $500 in the bank. Okay, that $500 is going to get 4% interest. Okay, at the end of the next month I now have the $500 in the bank that's gotten interest twice now. Now I've got $1,000 in the bank also that's going to get interest, and I'm putting another $1,000 in the bank. Okay, and then at the end of the last month, same thing. I had $500 in the bank from the very beginning that has added interest 3 times. I have $1,000 in the bank that got interest twice. I have another 1,000 that got interest 1 time, and I have this current 1,000. So if I add up all of these values in this last column, I get $3,684. Okay, so going back to my spreadsheet, if I look at those examples, here's example 4A. Okay, so example 4A, there were 2 periods, 1, 2. I started off with $10,000. I collected 5% interest, and I did that twice, and that's how I'm getting that $11,025. Here's example 4B. Now example 4B, remember I told you you can't figure it out without using logarithms. So in this case, I wanted to start with $500 and I wanted to end with $583. I wanted to know how many periods would it take. And you'll notice that after 2 times, the formula came up with $583. If I had a different value there for the 583, let's say that I drag this down a few more, and I drag this down a little bit. So let's say I was looking for $734, the answer would be 5. Okay, and our last example here, So on this one, we just needed to change the rate to figure out. So if I change this to 10%, you'll notice that I get the 1210 that I'm looking for. So it could be a situation where you just play around with this number until you get what you want. Hope this helps.